Welcome back to the next lesson on stoichiometry. So here we have a question to start off with. Prozac, with its molecular formula of C17H18F3NO, is widely used as an antidepressant globally because it inhibits the uptake of serotonin by the brain. So your job in the first few minutes of this lesson is to find its molecular mass. So pause the video now and come back once you have an answer and we'll go through it to see if you're correct. Okay, so welcome back. Now remember that the relative molecular mass is going to equal the sum of all the relative atomic masses in the particular compound. Okay, so the relative atomic mass of carbon is 12. The relative atomic mass of hydrogen is 1. The relative atomic mass of fluorine is going to be 19, if my memory serves me correct. The relative atomic mass of nitrogen is going to be 14, and finally the relative atomic mass of oxygen is going to be 16. So our job is to pretty much just add all these numbers up in terms of the molecules. So we'll get 17 times 12 plus 1 times 18 for hydrogen plus 3 times 19 for fluorine plus 1, just make a slight mistake there, 1 times 14 for nitrogen plus 1 times 16 for oxygen. Okay, so if you add all those values up, do the cross multiplication, you should get an answer of, if we just change the colour, 309. So hopefully you got the same number as I did. If not, you need to go through your notes to make sure you understand how to calculate relative molecular mass. So, what you have to do is to consider the mole. So what's the mole? Remember in our last lesson I did slightly mention it in terms of from relative molecular mass to molecular molar mass. This is what this lesson is going to be about. It's going to be understanding the concept of a mole, which is critical to your understanding of stoichiometry and chemistry. So the mole is a measure, a unit of counting. Okay, it's similar to, say, a dozen eggs, except instead of a dozen being 12, a mole is 602 billion trillion, or 602 000 000 000 000 000 000 000. Now that's a bit of a mouthful, so rather than saying that number, we use standard form and say that a mole is equal to 6.02 times 10 to the 23. So if you have a dozen eggs, you have 12 eggs. If you have a mole of eggs, you're going to have 6.02 times 10 to the 23 eggs. Quite a lot of eggs. And this number is known as Avogadro's number, and it's called Avogadro's number in honor of the Italian chemist who discovered it, Amedeo Avogadro. And what he did is he studied quantities of gases and discovered that no matter what the gas was, there was the same amount of molecules present in the gas for that particular volume. So how big is a mole? Just to get an idea of 1 times 10 to the 23, that's quite a big number. Lots of zeros. Okay, so it's enough for the soft drink cans to cover the surface of the Earth to a depth of 200 miles. That's quite deep. Consider it this way: if you had Avogadro's number of unpopped popcorn kernels and spread them all over the US, the country would be covered in popcorn to the depth of over 9 miles. So you can clearly see it's a very big number. And finally, if you are able to count the atoms at a rate of 10 million atoms per second, it would take you about 2 billion years to count the number of atoms in just 1 mole. And remember, there's a lot more than 1 mole of atoms in most substances. Okay, so let's just check if we have an understanding of what a mole actually represents. So suppose we invented a new collection unit called a Chinooga. Okay, so one Chinooga contains 8 objects. So here we have 3 questions in which you need to answer to show you understand what a mole is in relationship to counting. Okay, so pause the video now and we'll come back and see if you get the 3 questions correct. Right, so welcome back. So question number 1 says, how many paper clips are there in one Chinooga? Okay, so we're told that one Chinooga contains 8 objects, so there must be 8 paper clips, or C, in one Chinooga. Next question says, how many oranges are in 2 Chinooga? So if you had 2 Chinooga and one Chinooga takes 8 objects, there must be 2 times 8, because remember one Chinooga is 8. So it must be C also, 16. And the final answer says, how many Chinooga contain 40 gummy bears? Well, if one Chinooga contains 8 gummy bears, or 8 objects, then 40 gummy bears must be 5 Chinoogas, because 5 times 8 gives 40 objects, 40 gummy bears. So, let's look in more depth at the mole. So, a dozen cookies, or a dozen eggs, or a dozen muffins equals 12 cookies, or 12 eggs, or 12 muffins. 1 mole of cookies would then be 6.02 to the 23 cookies. A lot of cookies. Cookie Monster would be happy. 1 dozen cars is 12 cars. However, a mole of cars would be 6.02 times 10 to the 23 cars. And 1 dozen aluminium atoms is 12 aluminium atoms. However, when we're dealing with atoms, we're dealing with larger numbers, so we use the mole. 1 mole of aluminium atoms is 6.02 times 10 to the 23 atoms. Note that the number is always the same, but the mass is very different. If I had a dozen cookies, it would weigh about 120 grams. However, a dozen aluminium atoms, because atoms are so small, would weigh pretty much nothing. However, a mole of cookies would be quite heavy. You'll be looking at about 300 billion kilograms. Whereas a mole of aluminium atoms would be around about, top of my head, about 26 grams. Okay, so the mass is very different, although the numbers are the same. So the mole is abbreviated to mole, and that's a little bit easier to write than 6 times 10 to the 23. So a mole of particles, of any particle, contains 6.02 times 23 times 10 to the 23 of those particles, no matter what the particles are. So 1 mole of carbon contains 6.02 times 10 to the 23 carbon atoms. 1 mole of water, this time contains 6.02 times 10 to the 23 water molecules. And finally, 1 mole of sodium chloride contains 6.02 times 10 to the 23 NaCl molecules. And I put those molecules in kind of quotation marks because technically ionic salts are compounds, not molecules, so they're called formula units. Which remember from our structure and bonding lessons that it's pretty much a ratio of the sodium ions and the chloride ions. So you'd end up with 6.02 times 10 to the 23 sodium ions in combination with 6.02 times 10 to the 23 chloride ions. So here's a quick learning check to make sure you're on the right track. So 2 questions to answer. 1, the number of moles of atoms in 0.5 mole of aluminium, and 2, the number of moles of sulfur in 1.8 times 10 to the 24 sulfur atoms. So pause the video now, try and work out the answers, and then we're going to come back and look at the answers and see if you're on the right track. So welcome back. So the number of atoms in a half a mole of aluminium. Well, we know that 1 mole is 6.02 times 10 to the 23, so that means that half a mole must be half that number. So it must be C, 3.01 times 10 to the 23 aluminium atoms. So question number 2, number of moles of sulfur in 1.8 times 10 to the 24 sulfur atoms. Well, we know that 1 mole must be 6.023 times 10 to the 23. So all you have to do is simply divide the number of moles that you have by how many is in 1 mole. And you should get the answer of 3 moles of sulfur atoms. Kind of makes sense because C is far too large, and we know that 1 mole is 6.02 times 10 to the 23. So it's going to be B, 3 moles. So molar mass and of molecules and compounds. So the mass in grams of 1 mole equals numerically to the sum of the atomic masses. So this is where our last lesson came in. So 1 mole of calcium chloride is equal to 111.1 grams per mole. So 1 mole of calcium is 40.1 grams per mole, plus 2 moles of chlorine, which is going to be 2 times 35.5 to give 111 grams per mole of calcium chloride. Now you notice too we have now grams per mole because we now know that 1 mole is going to be essentially equal to the relative atomic mass. So that means that 1 mole of carbon is equal to 12 grams. This is the reason why we use this notation. So finally, 1 mole of, say, example of N2O4 is going to be 92.0 grams per mole because you've added up 14 times 2 plus 16 times 4 to give 92. Okay, so you can basically convert grams into moles and moles back into grams using the molar mass. This is called the calculations of molar mass. And the equation that we use is going to be the number of moles, N, equals the mass divided by the molar mass, capital N. Now be very careful that little m is mass, big M is molar mass, and that N equals moles, number of moles. Okay, and that's the equation we use. N equals little m over big M. So converting moles into grams. So aluminium is often used for the structure of lightweight medical bicycle frames. How many grams of aluminium are in 3 moles of aluminium? Okay, so pause the video now and let's see if you're on the right track. I'll be back in about 5 seconds. Okay, so welcome back. So this is the answer. So 1 mole of aluminium is about 27.0 grams per mole from the periodic table. That's its molar mass. So 3 moles must therefore simply be 3 times the number of moles. So it's going to be 3 times 27 to give an answer of 81 grams of aluminium using the equation. Okay, so the final learning check. The artificial sweetener aspartame, also known as NutraSweet, has a formula as shown, and it's used to sweeten your diet foods and soft drinks. So how many moles of aspartame are present in 225 grams of aspartame? Okay, so pause the video now, try and work it out, and then come back and we'll go through the answer. Alright, so let's go through the answer. So the equation that you're going to be using is going to be the number of moles equals little m over big M, mass over molar mass. So this one we have no problems. However, the problem is we haven't got the molar mass. So the way to get the molar mass is going to be equaling the sum of the ARs, which we've already kind of worked through in previous lessons. So it's going to be equal to 14 times 12 plus 18, because 18 times 1 is 18, plus 2 times 14, 2 times 14, nearly got it wrong, plus 5 times 16. Okay, so if we go through the numbers there, remember you're working, so it's going to be 14 times 12, which is 168, plus 18, which we've already got there. 1 times 18 is 18, plus 28, plus 5 times 16, which gives us 80. Okay, so that's going to give us a molar mass of, once I calculate it, 294 grams per mole. Remember now we have units because we're no longer relative molecular mass, we've got molar mass. Okay, then we go back to our equation here, which I'll just put in red, and plug in the numbers basically. So it's going to be 225 divided by 294. So 225 divided by 294, oops, 225 divided by 294 equals 0. Equals, do it in a different colour so we can see definitely what it is. Different colour I said, 0.77 mole of aspartame. Which kind of makes sense in a sense because 225, if it was 294 grams, it would be 1 mole, but it's a bit less, so it's about 0.77 moles of aspartame. And that's the answer. So hopefully you got that right. If not, go through your notes and see where you went wrong, so next time you don't make the same mistakes.